paths and cycles. So here we're going to look at moving from vertex to vertex along the edges of a network. Let's draw up a network. So we're going to have A, B, C, D. And let's join those. And we'll call this little e, f, and g. Now, a walk involves moving from vertex to vertex, and we can label the walk in different ways. I could say I could walk from A to B to C to D, and I could write it like that. I could just write the symbols along the edges as the walk, E to F to G. That'd be the same thing. Or I could write the vertexes and the edges all together. A to E, A along E to B, along F to C, along G to D. Okay, let's look at the same network. A, B, C, D, E, F, and G. Now, that was a walk. Here, we're going to look at a path, and a path is a walk that only visits a vertex once. So the previous one I did was also a path because it did only visit the vertex once. So A, B, C, D is a path because it only visits each one of those vertexes once. But if the walk I did was A, B, C, B, A, here I'm visiting vertex B twice and A twice, so that's not a path. So this one is a path, but this one is a walk. Now, if I add in another edge here and call it H, and I do a walk from A to B to C to D back to A, this is what's called a cycle, because my starting vertex is the same as my finishing vertex. Just want to talk a little bit about connected networks and disconnected networks. So A, B, C, D. I'm going to draw another network over here. E, F, G, and H. Now, this one on the left I'm going to draw is going to be a connected network because every vertice is connected together. So this is a connected network. Now over here, if I connect these two and these two but nothing else, this is a disconnected network. Let's have a look at a slightly more complicated network. So we've got A, B, C, and D. Let's connect this to this, this to this, here to here, here to here, and let's make another connection and another connection. So drawing those all edges to my vertices. Now, is it possible to walk along every one of these edges only once? So, like I can give it a go. I can go from here to here, then here to here. So I've used those two. I've used this one now, and this one, and this one, and this one, but there's no way I can get to CD without crossing another one again. And it doesn't really matter where I start, this is actually going to be impossible. It's going to be impossible for me to trace here and only move along an edge only once. And there is a way to know this without having to try all the paths yourself. And That's if exactly two vertices have an odd degree, or no vertices have an odd degree. It would be possible. So what we can do is we can list all the vertices, all the vertices, A, B, C, and D, and all their degrees. So let's have a look. So A has degree 3 because it has 3 edges coming out of it. B has a degree of 5 because it has 5 edges coming out of it. C has 3 and D has 3. So they're all odd numbers. So it becomes impossible because it'd only work if only 2 of these were odd or none of them were odd.